Alright, so now we're doing the sensitivity analysis, but it says find the range of values that the total capital, that's one of our constraints, can assume. So what are the range of values that we can have for the total for our capital? Alright, so that's this equation here. You'll notice that is changed from what I originally typed in the review packet. So you should have got my email that said change this to capital. If not, just follow this example and this elucidates the same principles. So our maximum point is here. This is where our best point is. This was the values for our best point. So that's where the red and the blue line meet. So our steps were to first take our systems of equations. So that's this system here. Those are the two lines that meet at our best point. All right. Now we want to see what the range of values can be for the total for capital. So that's where we're going to add our h. So we should write this twice so we can solve twice. Now because there's three lines, there's a little quirk, or it's a little more interesting, which will require some more explanation at the end. But the initial thing is still the same. Same process as what we did before. So we have the area, which is x plus y equals 200, and then we have the capital. So not to confuse you, I guess I'll write the same one on top, not that it matters whatsoever. So we have x plus 2y equals 220 plus h. Again, we're worried about the intersection of the lines, so we don't really care about the inequalities. So what I'm going to do is multiply this by a negative. Multiply everything through here by a -1, because that'll cancel out my x's. So it's minus x minus y minus 200. And I didn't rewrite it just to save space. Although, I should write it twice, right? So I'll write this one twice. Alright, because I'm going to solve for x and y independently. Just makes it easier later. So we get x's cancel out. 2y plus negative y is y. 220 plus negative 200 is a 20 plus h. Alright, so that worked out to be really easy. We didn't have to divide anything. There was no coefficient. Alright, now I'm going to multiply this by a -2. So I have negative 2x minus 2y equals negative 400. Alright, now I add those. That will eliminate the y's, because 2y minus 2y is 0. X minus 2x is going to be a minus x. 220 minus 400 is going to be a minus 180, and then that's plus h. I want a positive x, so I divide everything by a -1. And I'm going to get x equals positive 180 minus h. Alright, so those are the coordinates of where these two lines meet. Okay, I guess I could have done it in red, whatever. What that means is if we don't add anything to the capital total, well then this is just our original system of equations, the blue and the red. Well, they are solved at this point. This is the x and the y that solve that system. If I add h to the blue line, that in effect, so let's draw another blue line here right over that. Okay, adding h has the effect of, let me extend this, I'm sorry. Y. Shouldn't be doing that. Alright, so here we go. When I draw the right line here, alright, beautiful. When I add h to this, that essentially is like sliding that up, right? Adding to this number increases the y-intercept, so I'm moving this up, which changes where the red and the blue lines meet. So if I add something to it, so it moves it up a little bit. So now let's say I add a little bit. My coordinates of where they meet are new. Alright, and this is how I find the new coordinates. So wherever my new blue equation meets, my red equation, this is the coordinates of that. Alright, now we do know, just like before, that the y coordinate definitely has to be positive and the x coordinate has to be positive. Those are limitations on our system. Okay, so that's the same as before. So I know that this has to be more than or equal to 0, and this has to be more than or equal to 0. It has to be positive. Alright, so if I have 20 plus h is more than or equal to 0, then minus 20 from both sides, I get h has to be more than or equal to negative 20. That's one of the limitations on h. Alright, now if I know this has to be more than or equal to 0, add h to both sides, and I get 180 is more than or equal to h. Alright, so that's another limitation on h. So, if there were only two lines, if we only had the x-axis, the y-axis, and then the red and the blue, and that was our entire system, we'd be done. H would have to be between negative 20 and 180. Since there's this third line, there's another constraint on h that we have to consider, because if we change h too much, then this is no longer, our feasible point is no longer where the red and the blue meet. Right? If I move the blue too high up, well, now the red and the blue meet way up here, having nothing to do with our feasible region, not even close, right? So that is no longer, this system of equations is no longer valid because it's not even part of our feasible region. If I add a big enough number here, it gives me a new blue line like this, and now they don't meet on the feasible region, so solving the system has nothing to do with it. So where can we move it to? We can move it to here. That's another limitation on h. So that tells us that the y value at this point here, the y value of our solution where the red and blue meet, has to be below this intersection point of the other line. So that tells us that the y value here is 40. So this y has to be less than 40. Alright, because if it's not, then our blue line is moved so far, we've added so much to this equation that it changes this graph so much that the intersection of the red and the blue has nothing to do with our solution. Right? If I drew another line way over here that was one of our constraints, sure, it might be a constraint, but it would have nothing to do with the actual important solutions because it's not intersecting the feasible region. So we can't add an h that necessitates moving this past that intersection point. So that tells us that y has to be also less than 40, less than or equal to 40. Alright, similarly, because the x-coordinate here is 160, the x-coordinate has to be more than 60, right? Not only does it have to be more than 0, but if our x-coordinate was less than 60, right? Our x-coordinate of our optimal point now is 180. If we move here, our optimal point now is at 160. If we move further, then we're outside the feasible region. We're not touching any part of the potential feasible region. So our x has to be between 180 and 60. So we actually have to write that x has to be more than 60, more than 160. Either limitation, the extra limitation on our y because of this third equation, or the limitation on x is going to give us the same result. So if I say that 40 has to be greater than or equal to 20 plus h, because our y coordinate has to be less than 40, minus 20, and h has to be less than or equal to 20. Alright, if I use that limitation on the x, the fact that x has to be more than 160, not just more than 0, but it actually has to be more than 160 to be past this point, then we get 160 has to be less than, or x has to be more than 160. So then we minus 180, and I get negative 20 is less than or equal to negative h, divide by a negative 1, and we get 20 is greater than or equal to h. Gave us the same result. So all these limitations are true. This has to be true, this has to be true, and this has to be true. So if h has to be less than 20 and less than 180, this actually doesn't even matter, because if you're less than 20, you're automatically less than 180. So truly, with this 3-equation system, our h, what we're allowed to add to this constraint, right, this total, what we're allowed to add or take away, that will keep our feasible point between the same two lines and not allow it to change feasible points and just satisfy the fact that the coordinates are positive is h between negative 20 and 20. All right, since the total is already 220, that means that the total capital must be between what it is now, 220 minus 20, which is 200, and 220 plus 20, which is 240. That's the limitation on the total capital. Now, that's only because it was a three-line system. Otherwise, this limitation, h being more than negative 20 and h being less than 180, would be fine. If we didn't have this green line, it's just a two-line system, and it's almost the exact same as what we did in class, and you're done when you have these two. And you just have to say the total minus 20, the total plus 180. All right? Any other questions? Feel free to come see me early in the morning, and I'll talk to you later.